Welcome my dear student. So in this concept booster series, I am going to tell you about the solid angle and its application. The solid angle is one of the important parameters to solve some of the interesting problem with much ease without doing any kind of integration. So I can do it with the concept of solid angle. So this solid angle concept can be applicable in many problems, like in case of electrostatics, I can apply that, or in case of magnetism, I can apply that, or in case of optics also, I can apply that. So in this lecture series, I am going to discuss about the solid angle and its application. Okay. So let us start the session. So there are two types of angle. One is called the plane angle and one is called the solid angle. Now whenever the figure is 2D kind of figure, so I can draw this circle in a plane paper. So that means I am measuring the angle plane angle. So once I measure this angle, the theta is nothing but the plane angle. Now how to measure this theta? Theta should be equal to L by U. What is L? L is the arc length. If I move from point A to B and that arc is measuring a length of L and that arc is measuring an angle theta at the center O, then theta is known as the plane angle and unit for this theta is basically measured in terms of rate. Now if I go for the solid geometry, that is just now we go for the 3D geometry, let us say inside a sphere. So inside a sphere, at the center of the sphere, if I move about a particular direction, so that I can measure an angle within the solid, and within the solid I can measure that angle. So that angle is known as the solid angle once I am measuring this area. I am observing this area A from the center of the solid sphere. So that angle that has been within the solid material is basically known as the solid angle. The solid angle is defined as sigma, that is equals to A by R square. Now what is A? A is the area which has been observed from the point O, and all the points on A must be at the same radial distance R. Now unit for this solid angle is basically square area, abbreviated as SR. Okay, so this is the concept of solid angle. So once I move inside the solid, that means now I can visualize the solid angle. So let us say I am visualizing this area on this particular solid surface. So this area is A. So all the points on the solid surface are at equal distance from the point 2. So the inside the solid angle, the angle that I am measuring is basically the solid angle. Okay. So that solid angle has to be measured inside the solid. That's why the name is solid angle. And for that, sigma is equals to A by R square. A by R square. Now that area has to be kept in mind. That area is such that on all the points on the area, the distance of all the points from the point O should be equals to same. That is that R distance. So what is R? R is the distance of all the points on the area itself measured from the point O. Okay. So that is the solid angle concept. Now if I go for the solid sphere, so for the entire solid sphere, the solid angle is 4 pi. Okay. Why? Because the area of the solid sphere is basically 4 pi R square surface area. Now the term that comes in front of R square, that is coming as the solid angle. So once I go for the hemisphere, the area is how much? Half of that, that is 2 pi R square. Okay, so 2 pi is coming as a solid angle. Similarly, if I cut this hemisphere into another half, so that means I am getting the quarter sphere, 1/4 part of the sphere. So that means now the area is equals to how much? Pi R square. Surface area, I am talking about the surface area. This curved surface area is basically 8 pi R square. So now the solid angle is pi. If I cut it half, then the solid angle become pi by 2. Cut it again half, solid angle become pi by 4. Like this way, you are getting the solid angle within the solid itself. And mind it, whenever you are calculating the solid angle, so let us say I take one elemental area, that's why I consider this area. Okay, so this area is at a distance of R from the center. Similarly, if I consider that area, so that area is also at a distance of R from the center. Okay, so all the area should be at the same distance from the center itself. Then only I can apply the form. Okay. So let us do this analysis. Let us say there are two areas. So one is this, let us say A1 area, which is at a distance of X. Let us say I am taking another area A2 on this particular conical shape geometry. Let us say A2 area. Once I calculate the solid angle, so for this A1 area, the distance of all the points on the A1 area from the point is X. So that same distance is 2x for the A2 area. So if I calculate the omega 1 for this particular figure, so that should be equal to A1 by X square. Similarly, if I calculate the omega 2 for the same geometry, that should be equals to A2 divided by 2x whole square. Now, since I am measuring the same angle within the solid for both the situations, that means this angle is same for both the area, that is A1 or A2. That means omega 1 and omega 2 both are equal. So omega 1 is equals to omega 2. That means what you can say that A1 should be equals to A2 by 4. That means A2 should be equals to 4 times of A1. That is the reason. That is the area, as I am changing the area, that is the solid angle is not going to change if I maintain that particular ratio. That means if I take another area over here, then it will give the same solid angle. Only thing is that the area is now going to be changed. Okay. So in the formula of solid angle, sigma equals to, if I write dA by r square, what is dA then? So dA is basically the perpendicular to the r. So I should write in this form, that is dA perpendicular divided by r. Why? Because area should be perpendicular to the r direction. If I take an elemental area, let us say I am taking an inclined area like this area. Now this area, all the points are not perpendicular or not equal distance from the point O. So now I have to take, let us say this angle is theta. Let us say this angle is theta. So if I say this area is A prime, so the horizontal component of area should be A prime cos theta. Okay. So initially I took the area as this area. So this is the area of the cone. Okay. This area is A prime. A prime. Now this area is at an angle theta with the horizontal. So component of area along the horizontal direction. That means I want to calculate what is the projection of that area. So this area. So I want to calculate this yellow area. So what is that area? That area, if I say A, that should be equals to how much? That should be equals to A prime cos theta. Okay. Now all the points on this A area are at equal distance from the O point. So now we can calculate the solid angle. Sigma should be equals to A prime cos theta divided by r square. Okay. So this is the idea that whenever you are taking the area, so that area should be perpendicular to the r direction. Okay. Now we want to calculate the solid angle. For this solid angle, let us say out of the entire sphere, I cut a conical portion like this way. So this is the part of the sphere where the center is lying at O. Okay. Where the center is lying at O, I am taking the part of the sphere. So this is called the cap. So this is the cap geometry. Okay. So I want to, so all the points on the cap are basically on the circumference or on the surface of the sphere. So that means all the points are at equal distance from the point O. So I want to measure the area. So area, if I calculate this area, what is that area? Really I can get the estimate of the solid angle. So in order to calculate the area, I have to do the integration. So for that I have to take the element. Let us say I am moving a distance of angle theta in this direction, and then further moving by an angle d theta, I reached a element of this particular section. Okay, this is the element that I am talking about. What is the shape of the element? Shape of the element is a ring-like structure. This is a ring-like structure. Okay. So now, for this ring-like structure, what is this width? This width of the ring is r times d theta. Okay, r times d theta. And what is the radius? Radius is this one, smaller. What is the smaller number? That is equal to r sine theta. Okay. So once I get the geometry of the ring, so for this ring geometry, I say this is the ring that I am talking about. So whose width is basically our r times d theta. And the radius is smaller. Okay. Now I want to calculate the elemental area of this ring. So what is the dA area? That should be equal to 2 pi small r into capital R d theta, the thickness of the ring. So put the value of small r. So that should be equal to 2 pi capital R square sine theta into d theta. So this is the elemental area that I am getting. So what is the total area? That is the area of the cap. That should be equal to integration of that number, 2 pi r square sine theta into d theta. That is the total area. So in order to get the total area, I have to put the limit. So what is the limit? That is from 0 to, let us say, alpha. What is alpha? Alpha is the semi-angle. So let us say this angle is the alpha over here. On the other direction, this is also equal. Okay, alpha is the semi-vertical angle of this cap portion measured at the point 2. That is the plane angle. Alpha is the plane angle. So if I integrate it, so 2 pi r square come outside integration of sine theta d theta. Now integration of sine theta d theta is basically cos theta. So integration of this will give the value of sine alpha, cos alpha minus 0. That means 1 minus cos alpha. Why? Sine theta equals to minus cos theta. So once I do the integration, so I am getting the answer as equals to 2 pi r square into 1 minus cos alpha. So that is the basically the A number. So once I get the A number, what is the omega number that is solid angle? That should be equals to A by capital R square. So A by capital R square means 2 pi into 1 minus cos alpha. So this is the relation between the solid angle and the plane angle. If the plane angle is alpha, then corresponding solid angle sigma should be written as 2 pi into 1 minus cos alpha. Now this is the formula that I am going to apply to solve different types of complicated problems, which will be much difficult if I go for the integration. Okay, let us start with the application part. So this is the sigma number that I am talking about. Sigma equals to 2 pi into 1 minus cos alpha, where what is alpha? Alpha is the plane angle. Alpha is the plane angle. So this is the relation between the plane angle and the solid angle. Now this is the first application that I am talking about. So here there is a point chart is there. So this is the point chart. Now there is a disc is placed at a distance of A from the point chart. Now you are asked to calculate find the flux to the area of the disc because of the point chart. Let us say the disc having a radius of capital R. Disc having a radius of capital R. So if I have to do this by the method of integration, then I have to take a small element at a distance of small r and a circular ring-like element like this way. For this ring element, I have to calculate the d phi number. What is the d phi number? That should be equal to E dot dA number. E vector dot dA vector. Now what is the electric field at this point? So because the point chart, the electric field will be in this direction. This is the E vector. What is that E vector? If I say that number is Z, so I should write that equals to K Q divided by Z square is the electric field. And that electric field is at an angle, and in this direction the velocity dA vector is there. So the angle is between these two is again alpha. So if I say this is a theta angle, so that is also theta angle. Okay. So now this E dot dA will give the value of KQ divided by Z square into dA is what? So 2 pi small r into dA dot dA. That means 1 cos theta will also come because of the dot product. So that is the d phi. So now you have to do the integration. Now once you are doing the integration, that means now the cos theta is also variable. What is the cos theta number? Cos theta number is equals to A by Z. So that should be equals to KQ divided by Z square into 2 pi small r into cos theta, that is equals to A by Z into dr. Now what is Z? Z is number that is equals to under root of A square plus small r square. Okay. So once I put this number, so ultimately what I am getting that KQ, in the numerator there is 2 pi and Z to the power 3 by 2. Now Z cube is there. So Z cube multiplied by Z cube multiplied by R dr. Now what is Z cube? Z cube is that number. So put it that number. So 2 pi K into Q divided by A square plus small r square whole to the power 3 by 2 into R dr. So you have to integrate that. Once I do the integration, that means you have to do the substitution. Then after that you have to do the integration. So it will take long time. Okay. So integration method is quite tedious and you have to do it. But if I want to avoid this integration, then I have to apply the concept of solid. Now for that, if I say this is the alpha angle, okay, corresponding to that, so the semi-vertical angle, alpha. So what is the solid angle? That should be equal to 2 pi into 1 minus cos alpha. This is the solid angle. So what is cos alpha? Cos alpha should be equal to A by that hypotenuse. Now what is that hypotenuse? That hypotenuse is equal to under root of R square plus A square. So I can write it that 2 pi into 1 minus a divided by under root of r square plus a square. That is a solid angle. I can calculate it with the help of the formula that we have derived recently. So once I calculate the solid angle, so for this small charge q, now for this point charge, what I can say, this point charge, if I place point charge over here, so it will produce the flux in a closed surface. So what is that flux? That flux should be equal to q by epsilon naught. So total flux emitting from this point charge is equals to q by epsilon. That phi total is equals to q by epsilon naught. And what is this q by epsilon coming out from the entire solid angle of 4 pi. So 4 pi solid angle is producing this kind of flux. But if the disk is placed over there, so with that disk, some portion of the solid angle or some portion of the flux is coming out. So I want to calculate this phi number. So what is the phi number? So that is the basic unitary method. So from the 4 pi solid angle, total flux that is coming out is q by epsilon naught. So what is the phi that is coming out from this solid angle sigma? So what is your answer? That should be equal to q by 4 pi epsilon naught into sigma. So once you calculate the sigma number, put it over here and you get the answer. Okay. So that will be your answer. That is equals to q into sigma. Inside the sigma there is 2 pi. So if I put it over here, so your answer should be equal to q by 2 epsilon naught bracket 1 minus a divided by under root of r square plus a square. Okay. That means with this method, you can apply directly to calculate the solid angle and you are bypassing this integration approach. Okay. So that's why the solid angle is most powerful concept which can be applied to calculate this type of problem. Now moving on to the next situation, let us say there is a bulb placed at a distance of 1 meter below the water surface. Okay. Now you are asked to determine the energy coming out from the bulb per second from the surface. Okay. Let us say this is the 1 meter depth. At that depth, the bulb is being put and it will illuminate the lower surface. Ultimately, the light ray will come. So, corresponding to 45-degree angle, can I calculate what is the solid angle inside the solid surface? So, I want to calculate what is the solid angle inside that. That is a sigma number. So, for that, 45 degree is the half angle. So, if I know the 45-degree angle, so corresponding to that, the solid angle should be equal to 2 pi into 1 minus cos alpha, means cos of 45 degree. Okay, that is 1 by root 2. So, solid angle is equal to 2 pi into 1 minus 1 by root 2. Okay, so this is the solid angle that has been formed due to the light ray. I want to calculate what is the total energy coming out. So, from the 4 pi solid angle, total energy coming out is equal to 100 joule per second because the bulb having a capacity of 100 watts. So 100 joule per second energy is coming out. So from sigma angle, what is the energy that is coming out? That will be your answer. So that should be equal to 50 into 1 minus 1 by root 2 joule per second. Okay. So these are very simple approach. So where you have to apply the concept of solid angle. Now moving on to the more application, let us say there is a cylindrical surface. Inside that surface, so a small charge q is being placed. Now we are asked to calculate the flux through the curved surface of the cylinder. So I know that whenever there is a small charge is placed inside an enclosure, so total flux coming out from the enclosure is equal to q by epsilon naught. Okay, so q by epsilon naught is the total flux that is coming out. So that is phi total. So there are two parts of the phi total. One is the phi due to curved surface. Another is that there are two flat surfaces, 2 times of phi due to flat surface. Okay, so out of 2 flat surfaces, let us say this is the 1 flat surface. I want to calculate what is the flux coming out from this, let us say this is the 5 flat surface. I want to calculate that. So for this surface, so can I define the sigma number? Sigma equals to how much? 2 pi into 1 minus cos alpha. Okay, so there is a solid angle for this particular surface. So again I can say that for the point charge, that is q point charge is there. So that point charge is taking the coming out, the flux is equals to q by epsilon naught, and that is basically covered by the 4 pi solid angle. So 4 pi solid angle is giving the flux is equals to total is q by epsilon naught. Now what is the flux given by this phi, given by the sigma? So that should be equals to sigma angle will give q by 4 pi epsilon naught multiplied by 2 pi into 1 minus cos alpha. So this is the amount of flux that is coming out from the one flat surface. So that is equal to how much? Q by 2 epsilon naught into 1 minus cos alpha. Now correspondingly, two flat surfaces give 2 times of this. So total flux coming out from these 2 times of flat surface is equals to how much? Then Q by epsilon naught multiplied by 1 minus cos alpha. Okay. So now I can calculate the phi due to curved surface. So what is the phi due to curved surface? Phi due to curved surface should be equals to Q by epsilon naught minus Q by epsilon naught into 1 minus cos alpha. Okay. So ultimately what I am getting that it is equals to Q by epsilon naught will cancel out. So it is equals to Q by epsilon naught into cos alpha. That will be your answer. So it is a simple application of the solid angle to calculate the flux to the curved surface of this. So what is the flux that is coming out from this surface, curved surface, that I have calculated. Okay. Now moving on to the next segment, where there are 2 point charges, Q1 and Q2. So since these two are the point charges Q1 and Q2, one is the positive, another is the negative. So whatever the electric field that is coming out from this, going in, enter inside the negative charge. Okay. So you are asked to calculate the at what angle beta will terminate at negative Q2. So you are asked to calculate the beta angle. So what I can say that whatever the flux that is coming out from the Q1 charge that is going inside this Q2. Okay. So flux emerging out from the Q1. So because of that the solid angle is alpha, corresponding to the plane solid angle. So flux coming out from A, so phi A, can I write it directly as Q1 by 2 epsilon naught into 1 minus cos alpha. 1 minus cos alpha. And that should be equal to phi terminating at point B charge. And that is equals to how much? That is equals to Q2 by 2 epsilon naught into 1 minus cos beta. Okay. So ultimately this 2 epsilon naught will cancel out. So I am left with 1 minus cos alpha. So 1 minus cos alpha is 2 sine square alpha by 2 into Q1 should be equals to Q2 into 2 sine square beta by 2. Okay. So 2 cancels out. So I am left with sine square beta by 2. That should be equals to Q1 by Q2 into sine square alpha by 2. So sine beta by 2 should be root of that number. So finally what I can write, sine of beta by 2 should be equal to root of Q1 by Q2 into sine of alpha by 2. So what is beta then? Beta should be equals to sine inverse of this number multiplied by 2. Okay. So 2 sine inverse of root of Q1 by Q2 into sine of alpha by 2. Okay. So that is your answer. So that means option number B. So this is another application where I am saying that the total flux coming out from the A charge is terminating at the B point. Why? Because Q1 is positive and Q2 is negative. Now another typical example where we can apply the concept of solid angle is to calculate the area of broadcast for a satellite. So if there is a satellite is there which is making an angle, so from this the signal is coming. Now this part of the earth is being observed by the satellite. So I want to calculate what is the broadcast region area. That means this area. So this area you want to calculate basically. What is the surface area that has been covered under the broadcast situation. So for that, if I say this is the center of the arc, the center of the arc O point. So if I join these 2 points, so these two are the perpendicular points. Okay, these two are the perpendicular points. So I want to calculate the solid angle for this region. So what is the solid angle for this region? So if I say this angle is theta, then this angle should be equals to our half angle, that is alpha should be equals to 90 minus theta. So first observation is alpha is equals to 90 minus theta. Okay, corresponding to this alpha angle, I can write the solid angle is equals to sigma, that should be equals to 2 pi into 1 minus cos of alpha, means cos of 90 minus theta, and cos of 90 minus theta is sine theta. So that is equals to 2 pi into 1 minus sine theta. So this is the solid angle subtended on the surface of the earth. Corresponding to the what is sine theta number? Now sine theta can be calculated as, if I say this is our sine theta number, so can I say this is the RE, radius of the arc? This is the radius of the arc. And let us say the height of the satellite from the Earth's surface. This point is at a distance of h from this Earth's surface. Okay, satellite is at a distance of h above the Earth's surface. So sine theta number can be written as equals to RE divided by h plus RE. Sine theta is equals to our RE. So 2 pi into 1 minus RE divided by RE plus h. So that is the solid angle. So once the solid angle I am getting at this number, so corresponding to the area of broadcast should be how much? Area of broadcast. So if I calculate this number, so that should be equal to 2 pi small h divided by RE plus h. So corresponding to that, I want to calculate the area. So I know that if the solid angle is 4 pi, then the area is 4 pi r square. If the solid angle is 2 pi, then the area is 2 pi r square. Okay. So corresponding to this solid angle, what is the area of broadcast? Then area of broadcast should be simply multiply this with r square. So area should be equal to 2 pi small h divided by RE plus h into r square, RE square. That will be your answer for the area of broadcast. So this is the portion of the Earth area, surface area, inside which I am observing the region of the satellite. Okay, satellite can broadcast this region on. So this is a portion of the area of the Earth which is being seen by the satellite. So that is called the broadcast region. So I can calculate that also depending on the concept of the solid angle. Okay. So hope you understand this. Thanks for watching the video. If you like it, please subscribe my channel.